Hi, I'm Rob, a product manager at NeuralMagic, and I'm here to introduce you to the SparseZoo, our library of pre-optimized or pre-sparsified machine learning models that you can instantly download, transfer learn to your data, and start running on the DeepSparse engine to get the performance and flexibility that the DeepSparse platform provides. Let's jump right in by simply going to SparseZoo.neuralmagic.com. So you can think of the SparseZoo as almost an optimized ML vending machine, in that you can pick and choose which version of which model makes the most sense for your implementation and target metrics. As you can see here on the left-hand side, we have preset filters that allow you to select from specific domains, like natural language processing or computer vision, as well as popular frameworks like PyTorch and TensorFlow, or even specific repos or datasets. SparseZoo currently has almost 90 available state-of-the-art machine learning models, with hundreds of recipes to choose from that allow you to fine-tune your deployment based on your desired combination of accuracy, performance, and size. And we're adding more all the time. SparseZoo also contains what we call model stubs, which enable you to reference any model on the SparseZoo in a convenient and predictable way. All of DeepSparse's pipelines and APIs can use a SparseZoo stub in place of a local folder, and today, I'll show you how to get started with stubs. So you might ask yourself, why would I need all of those versions of all those models? Well, not all models are built equally. Let's take ResNet 50 trained on ImageNet, for example. Yes, it's one model, but we have created 7 different recipes for this model, targeting unique performance versus accuracy constraints and targeted hardware that show where the value of sparsity plus the DeepSparse engine can be impactful. Hypothetically, let's say I want to do image classification on my 4-core laptop while I'm on a Safari to help me identify animals. Since I'm running the inference on my laptop and we'll be moving quickly on our Safari, I want my inferences to be super fast right on the CPU with the DeepSparse engine. I know that I need an image classification model that is sparse enough to performantly run on my laptop. To find a sparse model that will help me get performance with the DeepSparse engine, I can simply go to SparseZoo.neuralmagic.com, filter by image classification, and start exploring models. At a glance, I found this 95% pruned and intake-quantized ResNet 50 model that we were able to crunch from almost 91 megabytes dense down to just 3.3 megabytes while maintaining 99% of the baseline dense accuracy. This should do the trick, and since it was trained on ImageNet, it already has the animal classes I need so that I can run this model out of the box in the DeepSparse engine. If I wanted to transfer learn this model to a new dataset, let's say for specific animals and species from Africa, I could sparse transfer learn this model on a new dataset. Let's provide an industry example of how the SparseZoo can help kick off an ML solution and save time to production. Let's say I have a manufacturing use case where I have this video footage of my manufacturing floor and I want to implement a people counting function to make sure I know how many of my manufacturing staff are on the floor at any given time. And I need to do this at scale in a highly parallelized way, so speed is going to be most important. First, I'll go to the SparseZoo and filter my use case and dataset. I want to do object detection to track people, and lucky for me, the Cocoa dataset has a person class, so we can use that for our use case and code up a person class counter in the prediction output in our application. Let's go with this YOLO v5s pruned-quantized model that recovers to 94% of the performance for the dense baseline, and benchmark it to see if it will meet the target throughput for our use case. Let me show you how we would get started evaluating this model for our application with an AWS instance on the cloud. I'll be using a C6i 12x large instance for this demo. Now, I invite you to watch the dedicated DeepSparse engine video to learn more about our inference engine itself, but for now, we're just going to dive right in. Firstly, set up a fresh virtual environment. Secondly, I'll copy the stub for the model from the SparseZoo, in this case, YOLO v5s sparse quantized. Next, I'll just get onto my EC2 instance. Now, I'll install the DeepSparse engine with YOLO with a simple pip install. Now, to make sure I can get my performance with my manufacturing floor people counter, we'll run a benchmark to see what performance I'll get on my instance for the sparse quantized YOLO v5s model. First, it'll download the model. Then it'll compile the model. Now it'll run a multi-stream benchmark, which is what I want for my manufacturing use case. If you wanted to benchmark a single stream scenario, you can set a flag in the benchmark command to --scenario sync. For this use case though, it should work just fine. Take a look at this average throughput. At this point, I feel pretty confident about this model on this instance for my application. And this is just the first step. To further evaluate, you can set up a server and run it through our Python API to start streaming your own data. It's as easy as that. All of this and a lot more is available through our extensive online documentation, as well as our other DeepSparse video demos available in the description below. So, that's just a brief overview of some of the features of the SparseZoo. We'd love to have you all join us and help us determine what models you would like to see in the zoo. So please join us on GitHub, in our open community Slack channel, or on the social media links listed right here. Thanks for watching.